Hello guys, welcome back to my YouTube channel. In today's video we will learn about Numpy package in the Python. The quality of the Python that it has variety of third-party libraries. So Numpy is one of the great third-party library. So we would need to always import the library first after installation. Here is some description about Numpy, that it is a fundamental package for scientific computing in Python. In addition, it is a Python library that provides a multi-dimensional array object, various array objects. There are three basically types of arrays: 1D, 2D and 3D arrays. It is one of the most important and widely used package. It can help you to do the computation on vector, matrix and high dimensional data structures in Python. So after installation we would need to import it first. We can do it by two ways. First, you can import Numpy, and another way which is more efficient to save our time, we give an alias. For example, import Numpy as NP. So NP is the short form for Numpy. So first we will look at 1D array. 1D means which has only one dimensional, one row or one column. So here we can say that my underscore vector is equal to NP Numpy, which we have already imported. Import Numpy as NP. So we are now using NP, and then np dot array, and in parentheses we will write 1 2 3 4 in the list, right? So here, for example, if we run this, and my vector, the same variable, we have printed it as 1 2 3 4 and it is array. And if you want to see the size, then the variable name my underscore vector dot size. So we will get the size of 1D array, and there are 4 elements, so size is 4. The second type is 2D array. So here I have written my underscore matrix is equal to np dot array, and then in double large brackets, so this will be your first row and 3 4 will be in the second row. Let us see. So 1 2 in the first row, and then 3 4 is the second row. So 1 and 3 would be first column, and 2 and 4 would be second column. So this way we can define 2D arrays. The more description here, the my underscore vector, 1D array and my underscore matrix objects are both type of the arrays that Numpy module provides. And now let us look at the type. Both are arrays, but one is 1D and the other is 2D arrays. Another function in the command is shape. So my vector dot shape, which was the 1D array, so we can see here that there are 4, and on the contrary my underscore matrix, which 2 rows and 2 columns, and then my matrix size is 4 because there are 4 elements but 2 rows and 2 columns. And if you want to see the shape using Numpy, we can do so by writing np dot shape of my matrix. So we will get the same 2 by 2, and the size would be 4. My matrix dot d type is basically it will give you the type of integer 32. It is basically size of the integer. We can change it using different options, but in this video I don't want to spend time on this. And then indexing, in the last video we already covered that how to index a list or array. So here the first row and first column we want to change by 8.5 to value. So let us see. Now because it is integer, so it has taken the type only first 8. So 8, earlier it was 1 2 3 4, but now it is changed to 8. So in this case, because the data type of the my underscore matrix was integer, so it has taken the integer value. But if you want to change the data type as like float or complex number, we can do so. Just m is equal to array, and then 1 2 3 4 same, comma, data type is equal to complex, d type is equal to complex. So it will convert the type. Sorry, here we want to write np.array. So it has converted into, so whole matrix, whole array m is now complex type, 1 plus 0j, 2 plus 0j, 3 plus 0j, and 4 plus 0j. Here I have added some description that the common data types that can be used with D type are integer, float, complex, boolean, object. We have already covered these in the last video. And then we can also change, we can also define the bit size of the data type is integer 64, 16, 1, float 128, or complex 128. We can do so. In Numpy package there is a option, command of line space. So x is equal to np dot line space, in parentheses 0 will be start, and then 10 would be the last point. So starting point and the last point, and then we have 25 points in between 0 and 10, including 10, both values, right? So we will get 25 values between 0 and 10. So if you want such type of data points, then we can get it using line space. One option in the Numpy package is to develop generate a mesh grid. So the one option is x comma y, because mesh grid has like some gridded points in x and y direction. So np.m grid, and then large bracket 0 to 10, and then 0 to 10. So 0 to 10 would be x, and then these would be y. So here you can see that in the x we get all 1 values, so 0 0 0 10, and then 1 on the contrary, in the y direction we get y values same of 10. And in Python we often need to generate random data. So one option is from numpy import random, and then np from numpy dot random dot rand. Random is the function to generate random numbers. So here we can see that there is 5 rows and 5 columns with random numbers. Every time you run, you will get different random numbers. And in case, for example, if you want to get random numbers which are normally distributed random numbers, so we can do so. just inserting n. So same np.random.rand n. So it will generate the random numbers, but normally distributed random numbers. It will follow the normal distribution pattern. And if you want to get a diagonal matrix of 3 rows and 3 columns, we can do so by writing np.diag diagonal, and in parentheses large bracket is stars 1 2 3 and then parentheses close. You will get a diagonal matrix. In diagonal matrix 1 2 3 will be in diagonal, and then all the rest of the elements will be 0. And if you want to get a matrix of like number of rows and number of columns of 0 values, then we can get it by np.zeros and then 3 rows and 3 columns. So it will generate a 0 matrix, means all values will be 0, and then np.ones, all values will be equal to 1. So 3 rows and 3 columns of the same 1. So after defining arrays, we can index them, manipulate them, in the first example, like we have a matrix. In the previous video we learned that the indexing in an array or a list can be done using square brackets. So here, for example, v is equal to np.arrange 0 to 10. If we have not defined any number here, then by default it will take 1. So it will define values from 0 to 9. 0 1 2 3 4 5 6 7 8 and 9. And in indexing means it will start, the first value is we can index by writing 0. So 0 to 0 1 2 elements we will get here. The last element is not displayed. So let us see. So 0 and 1. And if you want to get, if you want to see the entire matrix V, we can see that 0 to 9, 10 values. And then another command is reshape. So it will reshape the M. So first we are defining 0 to 19 here, and then there will be 20 elements, and then we want to reshape it in 5 rows and 4 columns. Before, so just we want to see that how it looks like. So 0 1 2 3 and then 4 5 6 7, so 5 rows and 4 columns. 0 1 2 3 4 5 6 7 and goes to 19. 5 rows and 4 columns, and we want to index it M large brackets 1 by 1. So 1 means second value. So second value, second row and second column. So second row, second column, we should get 5. So this is a way to index. And if you want to get so this is array, and this is second, to display second row. And if you want to get probably, so 1, 5, 9, 13 and 17. So second column in all rows. Second column in all rows. So here this is one row, first row and second column. And this is to get first value 0, first row and first column. And if you want to change the value, for example, second row, we want to replace all values by 0, and then third column by -1. Let us see. Here you can see that the third column all values are -1, and then second row all values, because first we got all values 0, and then third column we changed all -1, so instead of 0 0 0 in this row we got only -1 in this value. This is we have already covered in the last video. So -1 means it will start in the reverse direction from the last. Another way of indexing is first we define the index. So row index is 1, 2, 3, and then we insert in the brackets. So instead of writing 1, 2, 3, we have just written row indices, same, because we have not defined a matrix here. So we have defined 0, 1, 2, 3, 4, and then 10, 11, 12, 13, 14. So here we want to see the first, second, third and fourth value, second, 11, 12 and 13, and then 21, 22, 23, and then 31, 32, 33. Should work now. Here row indices we have defined, and then column indices 1, 2. Remember, index -1 means the last element, so it will start in the reverse direction. This is we have already defined up. This is to perform linear algebra. So first defining a, and then we are multiplying with 2, then a plus 2 into algebra, and getting shape. So this was all about indexing and defining arrays, how to reshape them, to manipulate different matrices. I hope this video helped you in getting introduction of the Numpy package in Python.